again to today's class. Let's see how to solve this problem on binomial theorem. The term binomial means two terms algebraic expression. That is, when you have two things given to you, this is one term, this is second term. 2 minus a is a two term, one term, second term. So plus or minus or both are used to get the number of terms. If you have x minus y plus a, this means three terms. That is 1, 2, 3. Three terms. That is trinomial, no longer binomial. But in this question, we want to concentrate on binomial. Now, in solving question on binomial, two principles can be used. That is combinatorial coefficient principle, which states that n combination r is equal to n factorial all over r factorial bracket n minus r factorial. You can also use Pascal triangle to get the combinatorial coefficient as well. This n combination r can be gotten using Pascal triangle. Look at simpler way of drawing it. Just write 1, 1, 1, 1, 1, 1 till where you want to stop. 1 plus 0, 1. 1 plus 1, 2. 1 plus 0, 1. 1 plus 2, 3. 2 plus 1, 3. 1 plus 0, 1. 1 plus 3, 4. 3 plus 3, 6. 1 plus 3 plus 1, 4. 1 plus 0, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus 0. So you continue that way. You can see it gave us a shape of a triangle. That is why we call it Pascal triangle, because it was introduced or discovered by a man called Pascal. Okay. Now, we have seen that we can use this pattern to get a combinatorial principle coefficient or this. So, let's see the question in full. The question says if the coefficient of x raised to power r and x raised to power r plus 1 are equal in the binomial expansion of this, find the value of r. For you to solve it, note that 19, which is the word power, bracket 19 minus r, what will it give you? 19 minus bracket 19 minus r. It will be giving you minus times this, minus times this. That will be giving you r, because this will cancel. Also note that 19 minus bracket 18 minus r. This will be minus times this minus 18 minus times this plus r. That will be giving you 19 minus 18, 1 plus r, or r plus 1. Any of it. They are the same. This is just a logic you can use, because you are looking at how can you get r as a power and how can you get r plus 1 as a power. Okay, now knowing that 19 minus this will be giving r plus 1, you recall it. Knowing that 19 minus bracket 19 minus r will also give you r, you have to recall it. Having them in our mind, what we have to do now is we now say, let's package this. We now say 19 combination, what is this? 19 minus r. We write the first term 3x. We now say this minus this. 19 minus 19 minus r, we got it to be r. We say raised to power r. We now say bracket the second term 2 raised to power of 19 minus r. That is to say, if you are to expand this using principles of combinations. What you do is you write 19 combination. We have gotten this because we said that this minus this will give you R. We now write it here. Now the rule said when you put the first term, say this minus this, it will give you this. Then write the second term, then carry this and put there. This is a way of expanding two terms algebraic expression. When you have two terms algebraic expression and you want to expand it using combinatorial principles, you have to say 19 combination a particular R, but at this point our R is 19 minus R because we said this minus this will give you R. To be able to get what the question says. Okay? After getting it this way, you come to the next one, which is the one on x plus 1. You now say 19 combination. What is our R? 18 minus R. Bracket, write the first one, 3x raised to the power of this minus this. This minus this will give you R plus 1. You say okay. Then you write 2 raised to the power of 18 minus R. You have gotten this, you have gotten this. Now, at this point, we'll now check out what are their coefficients, because they mention coefficients here. Simplifying this, we have 19 combination 19 minus R. This power will come to each times 3 raised to the power of R times x raised to the power of R, then times 2 raised to the power of 19 minus R. Now, making x raised to the power R to stand out, we'll write it so that it will stand out. Then we'll write 19 combination 19 minus R, then times 3 raised to the power R, then times 2 raised to the power of 19 minus R, then so it means that this is the coefficient of x raised to the power R they talk about. You come to this, you now say okay, 19 combination 18 minus R, 3 times 3 raised to the power of R plus 1 times x raised to the power of R plus 1 times 2 raised to the power of 18 minus R. We now make x raised to the power of R plus 1 to stand out. 19 combination 18 minus R, then 3 raised to the power R plus 1, then 2 raised to the power of 18 minus R. So this is also the coefficient of that x raised to the power R plus 1. So we have gotten their coefficient, and the question says their coefficients are meant to be equal for you to find value of R. So you equate it. You now write 19 combination 19 minus R times 3 raised to the power of R times 2 raised to the power of 19 minus R. You say it is equals to 19 combination 18 minus R, 3 raised to the power of R plus 1, 2 raised to the power of 18 minus R. So we have equated them. Now it's just to solve it. To solve it such that you get the final value of R, what we do is, you recall that this 19 combination 19 minus R. 19 combination 19 minus R simply means 19 factorial all over 19 minus R factorial, then bracket 19 minus 19 minus r factorial. So 19 factorial all over 19 minus r all factorial, then times the 19 minus r factorial. And you know that this minus this will give you only r. So we can clean it and write r factorial. We say it is equals, okay, times 3 raised to the power of r times 2 raised to the power of 19, 2 raised to the power of 19. Now, law of indices times 2 raised to the power of minus r. We say it is equals to, we come to this 19 factorial all over 18 minus r factorial bracket 19 minus 18 minus r will give us r plus 1 factorial because we got it before now. Then times 3 raised to the power of r times 3 raised to the power of 1. That is this. We have split this to this using law of indices, that is multiplication law. Times 2 raised to the power of 18 times 2 raised to the power of minus r. So what we do is we say this cancel this, there we go. Now this 2 raised to the power 18, 19, this 2 raised to the power 18, this will cancel this, leaving you with 2. Then this will cancel this. This will remain 3. Okay? Then you say 19 factorial. 19 factorial will cancel 19 factorial. Okay? Now, this is 18 minus r, right? And this is, now it is important to note that when you see 6 factorial, it means 6 times 6 minus 1 times 6 minus 2 and so on. That you'll be minusing by 1. So 6 times 5 times 4 times 3 times 2, that is it. If you have r factorial, it means r times r minus 1 times r minus 2 factorial times r minus 2 times dot till the wherever you want to stop. That's about factorial. But another way you can write it is r factorial is equal to r times r minus 1. You can put your factorial, or you can continue r minus 2. You can put your factorial without putting dot dot dot. It means that if you put it r factorial at the end, it means that you can continue to express it. Now, what we do, we apply this principle here. This is 18 minus r. And this is 19 minus r. Here, if you have 18 minus r and you minus another one, it will be giving you 18 minus 1, that is 17. You say no, you leave this. You come to this, 19 minus r minus 1, that will be giving you 18 minus r. Okay? So what we have here is, I will say 1 over 19 minus r, we are opening this factorial. Then 19 minus r minus 1, 18 minus r factorial. Then we have times another r factorial, which is this. Then times what? 2, which is what we have at the top. We now say is equals to 1 all over 18 minus r factorial. Now, when you talk about r plus 1 factorial, it is the same thing as writing r plus 1. R plus 1 minus 1 will be giving you r factorial, because r plus 1 minus 1, this will remain r. So what you now do is, you now say, let you open this factorial, bracket r plus 1, bracket r factorial. At this point, this will cancel this, then this will cancel this. Okay? So what you now do is you now say times 3 times 3. We have 3 at the top here. This will be leading you to simplify the final answer. 2 times 1, 2, all over 19 minus r equals to 3 times 1, 3, all over r plus 1. So cross multiplying 3 times this will be giving you 57 because 3 times 9 is 27. So 57. 3 times this will be giving you minus 3r equals to 2 times this will be giving you 2r. 2 times this will be giving you plus 2. Collecting like terms, you have 57 minus 2 equals to 2r plus 3r. Therefore, this will be giving you 55 equals to 5r. Our r will be equals to 55 over 5 is equals to 11. So we say finally our r is equals to 11. That is the final answer you will get in this question. Thanks for watching the video.